A database management system, or DBMS, is a powerful software tool that is essential in today's data-driven world. It allows us to store, manage, and retrieve data efficiently. Think of a library, where books are systematically organized and easily accessible. A DBMS is like the library catalog system, but for vast amounts of digital information. It helps in organizing data in a structured manner. From businesses tracking inventory to universities managing student records, DBMS plays a crucial role in various sectors. It ensures that data is not only stored, but also easily retrievable when needed. It ensures that data is organized, accessible, and reliable. This reliability is crucial for making informed decisions based on accurate data. Without a well-structured DBMS, organizations would struggle to keep their data in order. The lack of organization would lead to inefficiencies and errors. They would find it difficult to handle their data effectively, leading to potential losses and missed opportunities. Imagine searching for a single book in a library with no cataloging system. It would be nearly impossible to find what you need quickly. It would be a chaotic and time-consuming task, causing frustration and delays. A DBMS provides the necessary framework to prevent this data chaos, ensuring that information is systematically organized and easily accessible, thus enhancing productivity and efficiency. In the realm of data management, organization is key. Imagine a spreadsheet with customer information. If it's not structured properly, retrieving specific data becomes a nightmare. This is where the concept of normalization comes into play. It's akin to arranging books in a library by genre, author, and title. Normalization ensures that data is stored logically and efficiently. It minimizes redundancy, which means the same piece of information isn't stored unnecessarily in multiple places. This organized approach brings numerous benefits. These include data integrity, efficient storage, and easier data retrieval. Data redundancy, a common foe in the database world, occurs when the same piece of information is stored multiple times. Imagine a table listing students and their courses, where each row repeats the student's address along with their enrolled course. This repetition not only wastes valuable storage space, but also opens the door to inconsistencies. If a student's address changes, updating it in one row but missing others leads to conflicting information. This lack of data integrity can have serious consequences, from inaccurate reports to flawed decision-making. Normalization helps us combat these issues by ensuring that data is stored in its most concise and non-repetitive form. Normalization is a systematic process. It involves organizing data in a database to reduce redundancy and improve data integrity. Think of it as a set of rules that guide us in structuring our database tables. These rules, known as normal forms, ensure that data is stored efficiently and logically. By adhering to these normal forms, we create a more robust and reliable database. This makes it easier to maintain, update, and retrieve information. Normalization is not a one-size-fits-all approach. Rather, it offers different levels of normalization to suit specific database needs. Section 5. First normal form, or 1NF, is the foundation. The first step in the normalization journey is achieving the first normal form. It's the most basic level. 1NF dictates that each column in a table should contain atomic values, meaning indivisible units of data. Imagine a table storing customer details. If the name column contains both the first and last names combined, it violates 1NF. To comply, we need to split it into two separate columns, first name and last name. This ensures that each cell holds only one value, making the data more organized and easier to manage. Section 6. Second normal form, or 2NF, targets redundancy. Once a table meets the criteria of 1NF, we can proceed to the second normal form. 2NF aims to reduce redundancy by eliminating redundant data that depends on only part of the primary key. Consider a table that tracks orders and the products included in each order. If this table contains both order details and product details, with the product details repeating for each order of the same product, it violates 2NF. To achieve 2NF, we create a separate table for products, linking it to the orders table through a foreign key. Section 7. Third normal form, also known as 3NF, is all about achieving data integrity. Third normal form builds upon the second normal form. It focuses on eliminating transitive dependency. This means that no non-key attribute should depend on another non-key attribute. Imagine a customer table that includes customer details and the city they live in, along with the PIN code for that city. In this case, the PIN code is dependent on the city, not directly on the customer. To achieve 3NF, we need to move the PIN code to a separate table for cities, creating a more efficient and accurate data structure. Section 8. Beyond 3NF, we have Voice Cod Normal Form, or BCNF. While 3NF is widely used and effective, there's a more stringent form called Voice Cod Normal Form, or BCNF, which addresses certain limitations of 3NF. BCNF specifically addresses a type of anomaly that can still occur in 3NF, known as a redundancy anomaly. This anomaly can lead to data inconsistencies and inefficiencies. BCNF ensures that every determinant, which is a column that determines the values in other columns, is a candidate key. This means that no non-trivial functional dependencies exist unless the determinant is a superkey. In simpler terms, it makes sure that all the columns on which other columns depend are part of the primary key or a unique constraint. This eliminates redundancy and ensures data integrity. Implementing BCNF can be complex and may not always be necessary for every database. It often requires a deep understanding of the data and its relationships. However, understanding BCNF is crucial for database designers aiming for optimal data normalization. It plays a significant role in achieving a well-structured and efficient database design, free from anomalies and redundancies. Section 9. The benefits of normalization are numerous, and it's time to reap the rewards. Normalizing our database significantly reduces data redundancy, making our database more storage efficient. This reduction in redundancy also leads to improved data integrity. When information is stored in one place, updates are consistent and accurate. Furthermore, normalization improves data consistency. With reduced redundancy, there's less chance of conflicting information. This consistency is crucial for making informed decisions based on reliable data. Lastly, normalization makes data retrieval faster and more efficient. With a well-structured database, queries can retrieve information quickly and easily. Section 10. In conclusion, normalization is an essential aspect of database design. It's not merely about organizing data, it's about creating a robust, efficient, and reliable database. Normalization helps in structuring the data in a way that minimizes redundancy and dependency, ensuring that the data is stored logically and efficiently. By adhering to normal forms, we ensure data integrity, reduce redundancy, and improve overall database performance. This means that the data remains accurate and consistent, which is crucial for any business or application relying on that data. While different levels of normalization exist, the key is to choose the level that best suits the specific needs of the database. Each level, from the first normal form to the fifth, offers different benefits and complexities. Understanding and implementing normalization is crucial for anyone working with databases. It requires a deep understanding of the data and how it will be used, as well as the ability to foresee potential issues that could arise from improper data structuring. It It's a fundamental principle that underpins efficient data management. Without proper normalization, databases can become inefficient, slow, and prone to errors. By embracing normalization, we pave the way for better data-driven decisions and a more streamlined approach to handling information in today's data-centric world. This ultimately leads to more reliable and actionable insights, driving better business outcomes.